Today you will be solving a system of equations with an inverse matrix. So our first example, all we're going to do is we're going to write the linear system as a matrix equation in the form matrix A times x equals b. So the matrix A is just your coefficient matrix like we did with augmented matrices. So we'll have a column for the x's and the coefficient of our three equations is all 1. A column for the y's, so equation 1 we had a 3, equation 2 we had a 2, and equation 3 was a 4, and then a column for your z's. So in equation 1 we have 4z, no z, and 3z. Okay, so if you're confused, right, we had our x column, we had our y column, and we had our z column. Okay, so this makes up our matrix A. Now, when I multiply it, these are our variables vertically. And the reason why they are vertical is because when I go to remultiply, so we know the matrix A is a 3 by 3 matrix. Matrix X is a 3 by 1 matrix, which results in a 3 by 1 matrix. If we were to multiply them, we know we're going to have our row pencil into the column. So we would still have our x plus 3y plus 4z, which is the same thing as equation 1. So if I were to remultiply it, we would get what we started out with. And then we're going to have our equals are what our system equals for equations 1, 2, and 3. This is matrix B. And that's all you have to do is to write the linear system as a matrix equation. I want you to take a minute or two and try the example you tried. Hopefully you found for your matrix A, row 1 to be 6, 5, your row 2, 5, 4, your coefficient matrix X, Y, and then your B matrix, row 1, 13, row 2, 10. In our next type of problem, with this time we will write the matrix equation as a linear system. So as we stated before, the 3 by 3 matrix is the coefficient matrix of your three variables. So we know we'll have 2x, 0y, negative z. For equation 1, 0x plus 3y plus 0z for equation 2, and 1x plus 1y plus 0z is, and then what it equals. Top number is 6, that's what equation 1 equals. Middle number is 9, that's what equation 2 equals. The bottom number 5. And you can clean it up if you would like to. And you don't need to write the zeros. But if you leave it that way, that is okay too. And that's it. That's all she wrote. I want you to try the example you tried. In our next example, we are going to solve the system by writing a matrix equation, find the inverse of the coefficient matrix, and then multiply. So there are actually 4 steps that we will do with this type of problem, and I will zoom in some more so we have more space. The first thing we'll do is we will write our matrix equation. Okay, so we know we want matrix A, so that's our coefficient matrix. Times our variables vertically, x, y. It will equal the 12 and the negative 18. Okay, so that's what our instructions say. Solve the system by writing a matrix equation. Okay, so we need to talk about, if I have my matrix equation, how do we get x completely alone? Well, remember, you cannot divide matrices. However, if you remember your properties of exponents, if we multiply both sides by A inverse, right, and we have the same base here, like we have base A, we know the exponent of matrix A is just 1, right? So what do you do with your exponents if you have the same base and you're multiplying? Well, hopefully you recognize you add. So this would be like A to the 0 power times x equals A inverse B. And anything to the 0 power is 1. So x would equal A inverse B. Okay? But in order for us to find the solution, we have to find the inverse of matrix A. So that's our next step. So A inverse equals 1 over. Remember, we will do the main diagonal, or top left to bottom right product, minus the diagonal going the other way. So the 2 times 6. Also, remember, we're going to flip the position of the negative 4 and 2. So the negative 4 is now in the bottom right. The 2 is in the top left. And we switch the signs of the other diagonal. So the 2 in the top right is now negative, and the 6 in the bottom left is also negative. And now all that we do is we clean it up. So A inverse is equal to 1 over negative 8 minus, well, no, 6, if I could multiply. Nope, that was right, negative 8 minus 12 Uh-oh, no one caught my mistake. I missed a sign. Right here, this 2 should be negative. Okay, 1 over 8 minus 12, that looks better. And this is still times 2, negative 2 for row 1, negative 6, negative 4 for row 2. Or 1 over negative 4 times 2, negative 6, and negative 4. We distribute the 1/4 through. 2 times negative 1/4 is negative 1/2, and we'll have 1/2. Negative 6 divided by negative 4 is 3 over 2, and then negative 4 over negative 4 is 1. So all that we do next is, if we know x equals A inverse B, that means our matrix X from step 1 is xy equals, we'll have our matrix, our inverse equation, or matrix, inverse matrix for A. And we're going to multiply that by with what the system equals, 12 and negative 18. Okay, so then it becomes just a multiplication problem. Pencil in our cup. And here we go, we'll have xy equals 1/2 of 12 is negative 6, 1/2 of negative 18 is negative 9. Caught a drop sign here, so we just have to clean these up. And then this would be positive 6. Okay, and then minus 9. 3/2 of 12 is 36 over 2, which would be 18. And minus 18. So this will give us a solution of negative 3, 0. Woo. I would like you to take a couple minutes and try this example you try. Hopefully you found for this solution for this system using this method to be x is -2, y is -1. Okay, in our last type of problem, we're going to write the linear system as a matrix equation in the form matrix A times matrix X equals matrix B, and we're going to solve the system using the inverse that is given for the coefficient matrix. So we're going to follow the exact same steps. However, this one is a little bit nicer. So we're going to set up our matrix equation just like we did on the previous examples. And remember, our variables drop vertically and our system equals. Okay, so if you are confused, you notice we have our coefficient matrix here, right? We have our variables here, and then we have what the system equals here. And the other thing that you should notice is if we see here off to the right where it says the inverse of, now this matrix, does this inverse match our coefficient matrix A? It should. So what we're saying here that the inverse of our coefficient matrix is the following matrix. So we're saying this is already the inverse of matrix A. So all we have to do now is to x equals A inverse B. That's it, because we already have the inverse found for us. So we're going to substitute our matrices. Matrix X is XYZ. The inverse matrix is 3, -3, 1 for row 1, -2, 2, -1 for row 2, and -4, 5, -2 for row 3. And we multiply that by matrix B, 2 for row 1, 2 for row 2, and 1/2 for row 3. And all we have to do now is to multiply. So we know we can multiply because we have a 3 by 3 with a 3 by 1. And here we go. So for XYZ, we will have 3 times 2, which is 6, minus 6, plus 1/2. We'll have -2 times 2, which is -4, 2 times 2, which is +4, and -1 times 1/2 is -1/2, and -4 times 2, which is 8, 5 times 2, which is 10, and -2 times 1/2, -8, sorry, and then -2 times 1/2 is -1. Clean it up, 1/2 for row 1, -1/2 for row 2, and 1 for row 3. Therefore, our solution is 1/2, -1/2, 1. And that's it. I want you to take a few minutes and try this final example you try. Hopefully for this example you did come up with a final answer of x is 4, y is 9, and z is -4. It's official, you're ready to practice. The end.